Welcome to Raw Perfect classes. In this video, I will continue illustrations of Math class 10 according to CBSE and PSEB exam 2023. And these illustrations are related to chapters 5 and 6. First illustration that is given for the AP 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2. This series is given as a AP and we have to write first term and common difference D. This is a first term, second term, third term, fourth term. So that's why first term A is equal to 3 by 2 and common difference will be found by this method. Second minus first, third minus second, fourth minus third. Now first we will be write second term, then first term, third term minus first term, second term, fourth term minus 3 by 2 minus 1 by 2. Take the LCM. 1 minus 3 minus 1 minus 1 minus 3 minus plus over 2. When we solve it, minus 2 by 2 minus 2 by 2 minus 2 by 2. 2 cut with 2, we will find minus 1, that is a common difference, and D is equal to minus 1. Now, you have to keep in mind that if common difference is not equal of all terms, then it will not be AP series. In next example, which of the following list of terms of numbers form an AP? We have to find which series is AP series or which series is not AP series, and if AP series, then we have to find next two terms. In first question, we have given A is equal to 4 and D is equal to 6. How? Second term minus first term 6, third term minus second term 6, fourth term minus third term 6. So that's why common difference is equal to 6, and that's why it is a AP series. And next two terms will be fourth term plus D, that will be fifth term, and fifth term plus D, that will be sixth term. Now fourth term is 22 plus 6, 28. Fifth term 28 plus 6, 34 is the sixth term. Thus you can find next two terms. In second question, the second part, we have given A 1, D is equal to minus 1 minus 1 minus 3 in bracket minus 1 comma minus 5 minus 3 in bracket. D is equal to minus 2 minus 3 minus plus 1, then minus 5 minus plus 3 minus 2 minus 2 minus 2. And now this is also an AP series, and next term will be minus 5 minus 5 plus minus 2, means minus 5 minus 2, that is minus 7. Minus 7 plus minus 2, minus 7 plus minus and minus 9. These are next two terms. And third part, we have given minus 2A and D is equal to 2 minus 2 comma minus 2 minus 2 comma minus 2 minus 2. 2 minus plus 2 plus 2 4, 2 minus plus but sign minus, 2 4 but sign minus. So here you can see D is not equal. So that's why this is not a AP series. We cannot find next two terms. And in fourth, we have given A1. D is equal to 1 minus 1, 1 minus 1, then 2 minus 1, 2 minus 2, then 2 minus 2, 2 minus 1, 2 minus 2, then 2 minus 2, then 3 minus 3, then 3 minus 3. You can see difference not equal, so that's why it is not a AP series. We cannot find next two terms. Now next illustration. In this illustration, find the 10th term. For finding 10th term, we will use this formula. An is equal to A plus bracket start n minus 1 bracket close D. A is a first term, n is nth term, D is a difference. Here n is given 10, A 10. A is equal to 2, n 10 minus 1. D will be difference of these two terms. 7 minus 2 5, 12 minus 7 5. That means D is 5. 2 plus 10 minus 1 9, 9 into 5 45. You can see result is 47. In a next example, which term of AP? Which term of AP? 21, 18, 15 is minus 81. We have to find now which term will be minus 81. That means we have to find n. We have to find n. Also, is any term 0? Give the reason for answer. First of all, you have to take A is equal to 21, D is equal to 18 minus 21 minus 3, and an is given minus 81. You have to given formula this. An is equal to A plus n minus 1 D. An is given minus 81. A is given 21, n minus 1, n we have to find out, n minus 1 as it written, D is minus 3, minus 81, 21, here we have to solve this statement like this, minus 81 is equal to 21, plus minus minus 3n, minus minus plus 3, now 81 is equal to 21 plus 3, 24 minus 3n, minus 81 minus 24 is equal to minus 3n. Now it is minus 105 is equal to minus 3n. Minus minus cut, 105 divided by 3, that will be equal to 35. Now you can say that 35th term will be minus 81. Now next we want to know if there is any term, any n for which an is equal to 0. Here we have given an is equal to minus 81. Now we have given an is equal to 0. In such case, if such an n is there, then we will be find like this. 21 plus n minus 1 in bracket minus 3. We can repeat this formula again. For example, an is equal to A plus n minus 1 D. Here we write 0. A is 21 and we have to find, and D will be minus 3. 0, 21 minus 3n plus 3, and 21 plus 3 24, minus 24 minus 3 n, minus minus cut, n is equal to 24 by 3, 3 8s are 24, and 8th term will be 0. This is your answer. In the next example, we have given, check whether 301 is a term of least numbers. We have to check whether 301 is a term of least of numbers. For this we will be use this, we have given here an, and we have to nth term. We have to find nth term. So first of all, you have given A is equal to 5 and D is equal to second term minus first term, that is 11 minus 5, 6. Now put the formula. an is equal to a plus n minus 1d. an given 301, a is given 5, and we have to find, and d is given 6. 305 is equal to 5 plus multiply it 6 multiply and 6 and minus 6. 301 minus 6 plus 5 minus 1, and on the other side it will be plus 1. 6 and 302 over 6 n. 2 3s are 6, 2 1s are 2, 2 5s are 2 5s are 10, 2 1s are 2. Now you can see answer is 151 by 3. But n should be positive integer. So 301 is not a term of given list of number. We have to find it. It is not a term of this given list of numbers. In next question, we have to find how many 2-digit numbers are divisible by 3. For finding this, we first of all we have to write here those 2-digit numbers which will be division by the 3. 12, 15, 18 up to 99. And first of all we have to take here a is 12, d 3, 15 minus 12 3, an is equal to 99. An is equal to a plus n minus 1 d. An is 99, a is 12, n minus 1, n is n we have to find out. D will be 3, and 99. 99 is equal to 12 plus 3n minus 3. 99 is equal to 9 plus 3n. 12 minus 3, 9. 99 99 12 plus 3n minus 3. 12 minus 3, 9. 99 minus 9 is equal to 3n. Here 90 over 3n. 3 30s are 90, 90s. So we can say answer is 30th term. 32-digit numbers which will be divisible by 3. In next example, find 11th term from last term towards the first term. We have given this series. In this series, this is a first term and this is a last term. So a is equal to 10, d is equal to 7 minus 10, that is minus 3, and last term is L is equal to minus 62. You can write here L or you can write here AN. Both are the same. So AN is given minus 62 is equal to A 10 N minus 1 and minus 3D. Minus 62 is equal to 10 plus minus 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 3n minus minus plus 3 ones are 3. Minus 62 minus 13 is equal to minus 3n. Minus 75 over minus 3. Minus cut minus, and 3 25s are 75. So answer is 25th term. Now the 11th term from last term will be 15th term. If 11th term from last term will be 15th term, what will happen? So for finding this, A15 is equal to 10 plus 15 minus 1 minus 3. Then when we substitute values, then we find out minus 32. So 11th term from last term is minus 32. Now next example. In this example, in this illustration, we have given a sum of rupees, and this question is very, very important for exam point of view. A sum of rupees 1000 is invested at 8% simple interest per year, and calculate the interest at the end of each year. Do these interests from Interests form an AP. If so, find the interest at the end of 30 years making use of this fact. First of all, you have to remember that simple interest will be equal to P into R into T over 100. Principal rate into time over 100. Interest at the end of first year. We have to find first of all interest at the end of first year. 1000 multiply 8 multiply 1 over 100. 0 cuts with 0 and 80 rupees first term. And for the second term, 1000 multiply 8 multiply 2 over 100. Zeros cut with zeros and 160 is the second year interest. In the third year, 1000 multiply 8 multiply 3 over 100. Zeros cut with 0, 240 is the third term. Now you can see this is a series 80, 60, 160, 240. And after that you will find A is equal to 80. Here A is equal to 80 and D is equal to 80 because 160 minus 80, that is 80. Now put the values in the A30s because we have to find out interest at the end of 30 years. So A plus 30 minus 1 D. 80 is the first term plus 29 and 80 is the difference. When we solve this equation, we find 2400 will be total interest which will be paid at the end of 30 years. Now in next question we have given, in a flower bed there are 23 rose plants in first row and 21 in second row, 19 in third row. Means we have given series 23, 21, 19 and these there are 5 rose plants in last row. That means the last row plants will be 5. This is your AN and this is your A, and difference will be second minus first. 21 minus 23, that is minus 2. Now substitute these values in the formula. AN is equal to A plus N minus 1 D. AN is 5, A is given 23 and we have to find out minus 1 and D is find out minus 2 and 5 is equal to 23 minus 2N minus plus 2 and 5 minus 25 is equal to minus 2N. Minus 20 over minus 2 is equal to N. Minus cut with minus 2 times 20. N is equal to 10th term. We can say that there are 10 rows in a flower bed. Now next question is related to sum of n terms. Find the sum of first 22 terms of AP. We have given a AP. A is given 8, D is given 3 minus 8, that is minus 5, N is given 22. And here we use this formula. You should be keep in mind this formula. It's very important formula. S is equal to N by 2, 2A plus N minus 1 D. N is given 22 over 2, 16. How to come it? 2 multiply 8 plus, here we write like this, N is 22 minus 1 and D is given minus 5. 2 8s are 16. 2 minus 1, 21 minus 5 and 16. 21 multiply 5, 105. 105 minus 105 plus 16, we get minus 89. And now you can you have to multiply 89 with 111, then you can find out minus 979. Now you can say that the sum of first 22 terms will be minus 979. In next example, if sum of first 14 terms is given 1050, we have now given sum and we have given first term and we have to find 20th term. First of all, we have to put some formula. Sn is equal to n by 2 2a n minus 1 d. 1050 Sn, n is given 14, 14 by 2, 2 multiply, a is given 10, 2 tens are 20, n minus 1 means here we have to find n, which will be the term when sum will be 1050. So here n minus 1 d we will be right here. Sorry, we have not find n term. Here we have to find out common difference. We have to given Sn is equal to n over 2 2a plus n minus 1 d. We have given 1050, n is given 14 by 2, 2 multiply 10 plus n is given 14 minus 1 d we have to find out. 2 sevens the 14, 2 tens the 20 plus 14 minus 1 13 d, and here we will write 1050. 1050 is equal to 140. It multiplies 7 multiply 20 140 and 13 sevens the 91 d. 1050 minus 140 is equal to 91 and 5 minus 4 1, 10 minus 1 9 over 91 is equal to d. 91 is the 91. You can say 10 is the common difference. When we find the d is 10, then you have to now find out a 20th term, because in question we have to find out 20th term. A 20 is equal to a plus n minus 1 d. A is given 10 plus n is 20 minus 1 and d we have to find out, that is 10. 10 plus 20 minus 1 19, 19 times the 190 and answer will be 200. 200 is the 20th term. In next question, how many terms? We have to find how many terms of AP must be taken so that their sum will be 78. We have given 28, 24 is the A difference, any common difference, that is D is equal to 21 minus 24, that is minus 3. Sum is given Sn is equal to 78. Now substitute the values. Sn is given 78. N we have to find n by 2 as it 2 multiply A. A is given 24. 24 2 is 48. N minus 1 as it D is given minus 3. It will be multiplied this way. We find 78 is equal to n by 2 48 plus n 3n minus 3n and plus 3. 78 multiply 2 is equal to n. This 2 will be multiplied on the left side, and here 48 plus 3 51 minus 3n 156 is equal to 5n minus 3n square. You can write it 3n square minus 5n plus 156. And now make the factors. First of all, 3 multiply 156. 3 multiply with 156. 3 6 is 18. 3 5 is 15 plus 1 16. 3 1 is 3 and 3 plus 1 4. 4 68. Now make the factors. 2 2 is 4. 2 3 is 6. 2 4 is 8. 2 1 is 2. 2 1 is 2. 2 7 is 14. Now next we have to given 13 nines are 117. And 9 here 3 is the 9, 3 ones the 3. You can take factors. 2 2s are 4, 4 3 is the 12, 12 3 is the 36. No, you can take factors. 13 3 is the 39. 39. 2 2 is the 4, 4 3 is the 12. 1 4 or 5. You can take here factors 3n square minus in bracket 39 minus 51. Here 51. You can make factor 39 minus 39 plus 12 and outside bracket n plus 156 0. 3n square minus 30n minus plus minus minus 12n plus 156 equal to 0. And take the common 3n. n minus 13 3 is the 39. Here taken common 12. 12n. n minus 12 13 is the 156. So 3n minus 12 in one bracket, n minus 13 in another bracket. N is equal to 12 by 3, that is 4, and another 13. You can see here we have given two answers, 4 or 13. So both values n are admissible. So numbers of terms is either 4 or 13. Now next question. Find the sum of first 1000 positive integers, and second question, find the n positive integers. First 1000 positive integer means 1 to 1000 counting. We have to take on here. Let we assume s is equal to 1 plus 2 plus 3 plus 1000. In sum of first n terms will we use here, instead of comma we will use here plus sign, and formula will be Sn is equal to n by 2 a plus l, because we have given total, we have given last term, that is 1000, and we can use directly this formula, or you can use another formula. 1000 over 2, 1 plus 1000, and 2 5s are 10, and 200 200. 500 multiply 1001, and you can find this answer. And sum of first 1000 positive integer is this. Now we have to find n positive integer. So last term will be n. You have to put here formula Sn is equal to n over 2 a plus l, and n is n as it use n. A is given 1, l is given n. Now you can see answer will be n in bracket n plus 1 over 2. This is your answer. Sum of first n positive integers. Now in next question, find the sum of first 24 terms. We have to find sum of first 24 terms of the list of numbers whose nth term is given. Now we have given only this statement, and we have to find out first of all AP series. Then we will be find S24. For finding AP series, you should be remember that n will be equal to natural numbers 1, 2, 3, 4 up to unlimited. So here first of all we have to make first term. For first term 3 plus 2, we will be write instead of n, we will be substitute n's value 1. 3 plus 1 plus 2, that is 5. And in second term 3 plus 2, now n will be 2. 3 plus 2 to the 4, that is 7. And a3, 3 plus 2 multiply, here will be write 3. 3 plus 6, that is 9. A4, 3 plus 2 multiply 4. 3 plus 2 for the 8, that is 11. Now you can see we get series 5, 7, 9, 11. And in this series, A will be 5 and D will be 7 minus 5, that is 2. Now we substitute the formula. Write the formula of Sn is equal to n by 2 in bracket 2a plus n minus 1 d and S24. N is 24 over 2. 2 multiply. A will be 5 plus n is 24 minus 1 and d will be 2. 2 12s are 24. Here 12 again. Here will be 12. 2 5s are 10 plus 24 minus 1 23. 23 multiply 2 46. You can see 12 multiply 56. 12 6 are 72. 12 5 are 60. 60 plus 7 672 is your answer. This is the sum of first 24 terms of the list of numbers, that is 672. Next question. In this example, we have given a manufacturer of TV sets produced 600 sets in third year. 700 sets in the 7th year. And assuming that production increases uniformly by a fixed number every year. Production of first year we have to find, second we have to find 10th year production, and then we have to find total production in first 7 years. So first of all, we have to write here, we have given first, second, third and up to 7 years. And we have given A3. Third term is given, third year's term is given 600 and 7 years given 700. For solving this, A3 is equal to A plus 3 minus 1 D, that is equal to A plus 2D. And A7 is equal to A plus 7 minus 1 D, that is A plus 6D. Now you can write here A plus 2D is equal to 600, that is your first equation. A plus 6D is equal to 700, that is your second equation. From first and second equation, first equation minus second equation. When we subtract the second equation from first equation, we will find 8D is equal to 100. We find it sign change, and 4D is equal to minus 100. Minus cut, D is equal to 100 by 4. Means 25th will be D. Now you can find the first year's term. How to find first year term? You can find first year term by this method. A2 is equal to A3 minus D. 600 minus D is 25. So it will be 575, and A1 is equal to A2 minus D. That means 575 minus again 25, 550. This is for production of first year, 550. Now you have to find production in 10th year. How to calculate it? You can do it by adding series. A7 is given 700. A8 is equal to 700 plus D. That means 725. A9 will be 725 plus D. D is 25. When we add 750. And A10 is equal to 750 plus 25. That will be 775. This is your answer, 10th year. Total production in the first 7 years. Now here we have to find S7. S7 will be find N by 2 over in square bracket 2A plus N minus 1 D. You can put here formula 7 by 2 2a. A will be here 550 plus n is 7 minus 1 and d will be 25. 7 by 2 1000 55 2s are 110. That means 1100 plus 7 minus 1 6. 25 6 are 150. You can see here 7 by 2 multiply 1100 plus 150. It will be 1250. Now 2 6 are 12, 2 2s are 4, 2 5s are 10. And now 625. 625 multiply 7. 7 5s are 35, 7 2s are 14 plus 3. 14 plus 3 17, 7 2s are 42 plus 1 43. You can see answer is 4375 is your total production in first 7 years. Now next question is next illustrations will be start of chapter 6. First illustration. If you want to learn first two theorems of this chapter, you can watch my previous videos of related this chapter. In this video, I will not discuss that two theorems. I will continue from illustration. If a line intersects sides, this line intersect AB and AC of a triangle ABC at a point D and at a point E, which is parallel to, this will be parallel to BC. Now we have to prove AD over DB is equal to AE over EC. For proving this, first of all write DE parallel BC because it is given, and what we have to prove, AD over DB is equal to AE over EC. Now we have to write that we have to prove, and AD, here we will take according to theorem, first I will reverse it, DB over AD is equal to EC over AE. Now add both side. For proving it, add both side 1. DB over AD plus 1 is equal to EC over AE plus 1. When we take LCM, AD is equal to DB plus AD is equal to EC plus AE over EC. Now you can see DB plus AD is equal to DB plus AD is equal to AB over AD is equal to EC plus AE, that is equal to AC over AE, and it will be proved when we reverse it. Now in next illustration, we have given a trapezium. ABCD is a trapezium in which AB parallel DC, EF are points on non-parallel sides AD and BC respectively, such that EF parallel to AB. We have to prove that AE over ED is equal to BF over FC. First of all, let us join this line AC to intersect EF at point G, and now write AB parallel AB parallel DC, which is given in statement. EF parallel AB, it also given in statement. Now EF parallel DC. Now we assume EF parallel DC. Lines parallel to same line. We have to write here lines parallel to same line are parallel to each other. This line is parallel to AB and AB is parallel DC. So we can say that if EF parallel DC. Now in triangle ADC, in triangle, we take this side. In triangle ADC, EG, this is parallel to DC because EF parallel DC. So that's why we can say that here AE over ED is equal to AG over GC according to theorem first. Similarly, we can say that triangle C A B, in this FG parallel AB because EF parallel AB. So that's why we can write here CG over AG is equal to CF over BF. This is your second equation. From first and second equation, we can say from first and second equation, we find that these are common. These will be subtract, finish, cut, and we find AE over ED is equal to BF over FC. This is proved. Now next in question. In this question, we have given PS over SQ is equal to PT over TR and angle PST is equal to angle PRQ. Means we have given PS over SQ, PT over TR, and we have given PST is equal to PRQ. We have to given these two statements and we have to prove PQR is an isosceles triangle or not. We have those statements are given. First of all, we have to write them. PS over SQ is equal to PT over TR, and when PS over SQ is equal to PT over TR is given, that means according to theorem second, it will be proved ST is parallel to QR. Angle PST is equal to angle PQR because both are the corresponding angles. Both are corresponding angles which are given. And after that, you can see here we take here that ray BP and CQ intersect each other at a point A, and ray ER and FS intersect each other at point D. Means oh sorry, it's not related to it. In this question, now next point is we have given angle PST is equal to angle PQR. This is also corresponding angles and these are also given. Now angle P we have given here we can say that corresponding angles are angle PST is equal to angle PQR. These are the corresponding angles. These are corresponding angles and these are given in the question. Angle given in the question, angle PST is equal to angle PRQ, which is given in your statement. And from this we find out. This is your first equation, this is your second equation. From first and second equation, these will be cancelled and these will be finished. You can say angle PQR is equal to angle PRQ, and From first and second question, we find angle PQR is equal to angle PRQ. So that's why we can say that PQ is equal to PR. PQ is equal to PR and sides opposite the equal angles. So we can say that PQR is an isosceles triangle. So that's why we can say that this is a isosceles triangle. I will repeat it again. We have given this statement. This is your given statement. According to this given statement, we can say that theorems, according to 6.2 theorems, which is a inverse of which is a converse of BPT. According to converse of BPT, that means if a line divides any two sides of a triangle in the same ratio, then line is parallel to third side. So that's why ST parallel QR. Angle PST, angle PST, that is equal to angle PQR. This angle is equal to this angle, that is a corresponding angles. You can write here angle 1, 2, 3. You can write it like this. Angle 1 is equal to angle 2 because it is a corresponding angles, and you can write angle 1 is equal to angle 3 because it is a given in question. And we can say that from first equation to second equation, angle 2 is equal to angle 3. That's why we can say that PQ is equal to PR, and if PQ is equal to PR, that's why we can say that PQR is an isosceles triangle. Now next, now in this video I will discuss next theorem. First two theorems I have already discussed in previous videos. You can watch that video. And in this video I will discuss about third theorem that is given here. In this theorem, if in two triangles, we have given two triangles ABC and DEF, corresponding angles are equals, all corresponding, angle B is equal to angle E, angle A equal to angle D, angle C is equal to angle F. These are the corresponding angles. Then their corresponding sides, AB is equal to DE, AC is equal to DF, BC is equal to EF, are in the same ratio or proportion. Hence, two triangles are similar. If all these are equal, then we can say that both triangles are similar. It has we have to prove it. We can take here, this criteria is referred to as AAAA. That means angle, angle, angle. Criteria of similarity of two triangles. And this theorem can be proved by taking two triangles ABC and DEF such that here angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. Now cut DP is equal to, this DP is equal to AB and this DQ is equal to AC, and join the PQ. Triangle ABC and triangle DPQ. Angle P is equal to angle B is equal to angle P, angle C that is equal to angle E also. And so PQ parallel EF, and DP over PE is equal to DQ over QF. And if according to theorem first, and you can say also AB is equal AB over DE is equal to AC over DF. And from this we can say that AB over DE is equal to BC over EF. And so AB over DE is equal to BC over EF, AC over DF. And this proved that कि both triangles are similar. If two angles of a triangles respectively equal to two angles of another triangle, then by angle sum property of triangle, their third angles will also be equal. So here we implement AAA similarity criteria, which proved that these both triangles will be similar. Now you can say that for proving this theorem, first of all you have to write that these lines, you have to write first of all these lines. These lines very important, and this criteria is referred to as triple A angle criteria of similarity of two triangles. And this theorem can be proved by taking two triangles ABCDEF such that angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. Then we draw a line PQ which divides the DE at a P and DF at a Q, dP over PE and dQ over QF, and PQ parallel EF. And so if angle B is equal to angle E, then we can say that angle B is equal to angle P. If angle C is equal to angle F, then we can say that angle C is equal to angle Q. And so that's why dP over PE is equal to dQ over QF, and on the other side AB over DE is equal to AC over DF, and or you can say that AB over DE, and you can say it will be equal to BC over EF, or you can say AC over DF. And it's proved according to angle rules, when two triangles, two angles will be equal, then we can say that according to angle sum property of triangle, their third angle will also be equal. Therefore a triple A similarity criteria can also be stated here as follows. Now next, fourth theorem. In this theorem, if in two triangles sides of one triangle are proportional to the sides of other triangle and their corresponding angles are also equal, hence two triangles are similar. Now we have to prove that side. If all three sides are equal, then we can say that its angles will be also equal, and both triangles will be similar. We have to prove it. Here we take two triangles ABC and DF, AB over DE. Here we take two triangles same ABC and DEF. PQ is a parallel line. First we have to cut DP is equal to AB, DQ is equal to AC, and join PQ. Same line we have to write here, DP over PE is equal to DQ over QF, and PQ parallel EF. Angle P is equal to angle E because it is a corresponding angles. Angle Q is equal to angle F because it is also corresponding angles. So we can say that DP over DE is equal to DQ over DF is equal to PQ over EF, and all these sides are equal, so in proportion these are equal, so that's why we can say that BC is equal to PQ. And according to side rule, triangle ABC congruous triangle DPQ, angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. We will write this. In next theorem you have given in this theorem we use side angle side we have to prove it. If one angle of triangle is equal to one angle of other, for example angle B is equal to angle E, or the sides including these angles are proportional, AB equal to DE, AC is equal to DF, and BC is equal to EF, then two triangles are similar. We have to prove it. For this, we will be take as it same diagram ABC and DEF, in which PQ will be parallel line of EF and DP over PQ, DQ over QF. Now, same as it will be used, but you can write here, if PQ parallel EF, then triangle ABC congruous triangle DPQ. Angle A is equal to angle D, angle B is equal to angle P, angle C is equal to angle Q. So that's why triangle ABC similar to triangle DEF. Now next examples. We will take examples on these theorems basis. You can clear each and every theorem properly. If we have given PQ and RS, these are parallel lines, and we have to prove triangle POQ similar to triangle SOR. First of all, we have given PQ parallel RS. This is given, and angle P's alternate angle will be angle S, and angle Q's alternate angle will be angle R, and both are equal. Angle POQ is equal to angle SOR, that will be vertically opposite angle, that should be also equal. So here we use angle similarity criteria, and according to angle similarity criteria, both triangles will be similar. So that's it, that is proved. In next statement, we have find out angle P. Where is angle P? This is angle P. In triangle ABC and triangle PQR, first of all you have to write angle A is equal to angle A, that will be equal to, first of all you have to write AB over RQ. AB over, here we have to write AB over RQ. Why? Because AB over RQ, because 3.8 will be solved with 7.5. 3.8's double will be 7.6. That's why we say that AB over RQ, that is equal to 1/2, and on the other side AC over RP, that is given 3√3 over 6√3. 3√3 cut, 3 ones the 3, 3 twos the 6, that is 1/2, and BC over PQ, that is equal to 6/12, 1/2. Here SSS, triple S criteria, according to triple S criteria, we can say that AB over RQ is equal to AC over RP is equal to BC over PQ, and so that's why here angle will be, there both triangles will be similar, and angle C is equal to angle P. So that's why angle C is equal to angle P. Angle C will be equal to, this angle will be equal to P. First of all we have to find angle C. According to sum of angle property, here we use angle C is equal to 180 degree minus 80 minus 60, and we find 40 degree is angle C, so that's when angle P will be 40 degree. You can write it as it. Here it is written. You can write here angle C is equal to angle P, corresponding angles of similar triangle, and angle C is equal to 180 minus angle A minus B. We find out angle C 40 degree, angle sum according to angle sum property, so angle P will also 40 degree. In next example, we have given in this figure OA into OB is equal to OC into OD. We have to prove angle A equal to angle C and angle B equal to angle D. First of all, we have given OA into OB is equal to OC into OD. You can write it as in this way. OA over OC, OB goes to the denominator of OD. When we by cross multiply, we will find again this statement. But for solving the question, we write it in the form. We have angle AOD is equal to angle COB because these are the vertically opposite angles. Here we can say that SAS similarity. According to SAS similarity, both are the similar triangles, and angle A is equal to angle C. Angle D is equal to angle B because corresponding angles of similar triangle will be equal. In this example, we have given a girl of height 90 centimeter. This is a girl whose height is 90 centimeter. She is walking away from the base of a lamp post at a speed of 1.2 meter per second. If the lamp is 3.6 meter above the ground, find the length of her shadow. We have to find length of shadow after 4 seconds. For solving this equation, first of all, we will be assume AB denote to lamp post and CD denote to girl after walking 4 seconds away from the lamp post. From this figure, we can say that DE, this is a DE, this is a DE, this is the shadow of the girl, and so it will be assume X meters, and then BD is equal to this is given 1.2 meter. 1.2 meter multiply 4 after 4 seconds, it will be 4.8 meter. And so triangle ABE, in this triangle, in triangle ABE and a triangle CDE, we will find that angle B is equal to angle D because both are 90 degree. Both makes the 90 degree because lamp post as well as girl are standing vertically to the ground. And angle E is equal to angle E. In both figure, in both triangle, angle E is common, same angle. So triangle, according to AA similarity criteria, triangle ABE similar to triangle CDE. So if triangle both are similar, so we can say that BE over DE is equal to AB over CD. And here we will put the values, and BE is equal to 4.8 plus X over DE is given X, AB 3.6 and CD is 0.9. By cross multiply, when we by cross multiply, we will find that result will be 1.6. 4.8 plus X multiply 0.9 is equal to 3.6X. 9 8s are 72. 9 4s are 36 plus 7 43, and that will be 4.3 plus 0.9x is equal to 3.6x. 4.32 is equal to 3.6x minus 0.9x. 4.32 over 3.6 minus 0.9, that is 2.7 is equal to x, and 2.7 3 9s are 27, 3 1s are 3, 3 4s are 12, 3 4s are 12, and 9 16s are 144. So that's why answer is X is equal to 1.6. You can say that shadow of girl after walking 4 seconds, that will be equal to 1.6 meter long. Now next example is in figure 6.33. In this figure we have given CM and RN are respectively medians because these are the center of the lines AB and PQ. medians of triangle ABC and triangle PQ. If triangle ABC is similar to triangle PQR, now you have to given similar triangles. We have to prove that triangle AMC, triangle PNR, both are similar. And we, in second point, we have to prove CM over RN is equal to AB over PQ, and we have to prove CMB is equal, similar to triangle RNQ. For first equation, we have to write triangle ABC similar to triangle PQR. It is this statement is given in question. This is given. If both are similar, then we can say that its sides corresponding to proportionately equal. So AB over PQ is equal to BC over QR, CA over PQ, CA over PR. Angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. According to, we can say that SSS AAA criteria, we can say AB, these are the equals, these are equal and these are the similar triangles, and so AB is equal to 2M because it is the middle point. So that's why we can say AB is equal to 2 double of AM and PQ is equal to double of PN. 2AM over 2PN is equal to CA over PQ, CA over PR, and 2 cut with 2, and now you can find this AM over PN is equal to CA over RP. Angle MAC is equal to NPR. MAC is equal to NPR. AC is equal to NPR, because from this second equation it is proved that angle A is equal to angle P. So that's why we write here these are equal from second equation, and that is fourth equation. If both are equal, both angles are equal, then we can say that both triangles will be similar, means triangle AMC similar to PNR, according to SAS similarity, like this. Now we take CM over RN is equal to CA over RP. You have given here given in statement these triangles A, M, B, C, and in another triangle we have given R, Q, N, P. Now we will be write CM, because we will solve second equation. Second statement we have to prove CM over RN is equal to CA over PR. That is the sixth equation. CA we have given in a first equation CA over RP, AB over PQ. When we cut these two equations from sixth and seventh equation, we find that CM over RN is equal to AB over PQ. Now we have to prove third equation. In third equation, for proving the third statement, we will be write AB over PQ is equal to BC over QR. That is taken from first equation, and after that you can write CM over RN is equal to BC over QR, and CM over RN is equal to AB over PQ. This is given. This we have to we write it because we have to given BC over QR is equal to AB over PQ. We can write BC over QR's place AB over PQ value. That will be equal to 2 double of BM and double of QN. 2 cut with 2. CM over RN is equal to BM over QN. CM over RN is equal to BC over QR is equal to BM over QN. This is proved. So that's why here we can say side similarity. Triangle CMB similar to triangle RNQ. You can say that both triangles, this triangle will be equal to this triangle according to SS criteria. Now, next theorem is related to ratio of areas of two similar triangles. We have given two similar triangles, and the ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Means we can say here that we have to prove that area of triangle ABC over area of triangle PQR, that is equal to AB square over PQ whole square is equal to BC over QR whole square is equal to CA over RP whole square. We have to prove it. Square of ratio. Square of ratio. Ratio is proportion. AB over PQ is a ratio. Its square is equal to corresponding sides. All its corresponding sides. So we have to prove it. We are given two triangles ABC and PQR, and such that triangle ABC similar to triangle PQR is given in question. Now you have to prove it. First of all, you have to draw a line. We have two triangles ABC which are similar. This is a second triangle PQR. First of all, draw altitudes. In triangle ABC, AM altitude. In triangle PQR, PN altitudes for proving the question. Now first write area ABC is equal to 1 by 2 base into height. So 1 by 2 BC. 1 by 2 BC is a base, and height is AM. This is your first question. And in triangle PQR, 1 by 2 base is QR and height is PN. This is your second equation. And when we take it in proportion form, in ratio form, we can write it area of triangle ABC over area of PQR is equal to 1 by 2 BC multiply AM 1 by 2 multiply QR into PN. 1 by 2 cut with 1 by 2, we will find the BC multiply AM over QR into PN. Now you can take from triangle ABC one triangle AMB, and on the other from other triangle we take P and Q. We have to prove that both are equal. How to prove it? We can prove it by the angle similarity criteria, because in both triangle, angle B is equal to angle Q and angle M is equal to angle N. Both are equal to 90 degree, and according to A similarity criteria, both are similar. So if both are similar, then you can say that AM over PN is equal to you can say that AM over PN is equal to AB over PQ. So if AM over PN is equal to AB over PQ, then you can write here that triangle ABC similar to triangle PQR, which is given in question. Now you can say AB over PQ is equal to BC over QR over is equal to CA over RP. This is your third equation. And area ABC over area of PQR is equal to AB over PQ. Area AB over PQ multiply AM over PN from first and third equation. From first and third equation you can find it. You can write in place of BC or QR AB over PQ, because all these terms are equals. So that's why we can replace it. And after that you can find that when we replace AM over PN with the AB over PQ, then you can see that AB whole square, PQ also whole square. So if this is proved, then you can say that all other sides, corresponding sides will also be proved. Area of triangle ABC over area of PQR is equal to AB over PQ whole square is equal to BC over QR whole square is equal to CA over RP whole square. This will be proved. You have to prove only one, then other sides will be automatically equal. Now this question is related to this theorem. In this question we have given one line segment, that is XY, parallel to the AC of a triangle ABC. It divides the triangle in two parts. In two parts equally. Find the ratio AX over AB. We have to find AX over AB. First of all, you have to write what will be given. XY parallel AC is given. Angle BXY. Angle BXY is equal to angle A. Angle VYX is equal to angle C. Corresponding angles. And so triangle ABC and triangle XBY both are similar according to A similarity criteria. And area triangle ABC over area triangle XBY is equal to AB over XB whole square according to theorem, which is proved in previous theorem. Area triangle ABC is equal to area triangle XBY, and so area of triangle ABC over area XBY is equal to 2 by 1, and it will be equal to 2 by 1. That is your second equation. This is your first equation. Now you can see from first and second equation, it is proved that AB over XB whole square is equal to 2 by 1. That means this square will be come into on the right side. It will be converted into square root of 2 by 1. And answer will be XB is equal, XB over AB. Then it will be reverse 1 by root 2. And it will be both will be subtracted from both sides. 1 from 1 minus XB over AB is equal to 1 minus 1 by root 2. Here take AB LCM. AB 1 is the AB minus XB is equal to root 2 minus 1 over 2. And when we will solve it, AX over AB is equal to 2 minus root 2 over 2 is the answer. How to calculate it? 2 root 2 minus 1 over root 2 by rationalization method. This will be solved. 2 minus 1 minus root 2. When we solved it, 2. This is your answer. AX over AB. Now next question. In this question, you can see angle A CB, that is given equal to 90 degree. You can see this is a given 90 degree. And CD perpendicular to AB. We have to prove BC square over AC square, that is equal to BD over AD. We have to prove this. For proving this, first of all, write triangle ACD similar to triangle ABC. AC over AB is equal to AD over AC. How? When we rotate it, you can see B, C, A. When you rotate it, you can see this is 90 degree. This is a base, perpendicular, hypotenuse. And in this case, ABC or ACD. In this case, D is a perpendicular. So it's a base and this is a perpendicular, this is a hypotenuse. Here we take AC. AC means we take according to we take triangle ABC. According to triangle ABC, we take here AC, that is a base over hypotenuse, is equal to, on the other side, when we take it like this, we correspond, we reverse it. This is a C, this is a D, this is a A. Then in this case, AD is base, AC is a hypotenuse. When by cross multiply, AC square is equal to AB multiply AD. This is a first question. And similarly, triangle BCD, similar to triangle BAC, we can prove it. BC over BA is equal to BD over BC. BC square is equal to BA into BD. This is second question. From first and second question, it is proved that BC square over AC square is equal to BA multiply BD over AB multiply AD. Here we take second by 1. Second question divided by first question. And we find this B is equal to BD over BD. This is proved. Now in this next theorem, in this theorem we have given a ladder is placed against a wall. One ladder which is placed against a wall. This is a wall. This is a ladder such that its foot is at a distance of 2.5 meter from the wall, and its top reaches a window 6 meter window. Now find the length of ladder. We have to find here length of ladder. For finding the length of ladder, first of all, we use here Pythagoras theorem. You have to use here Pythagoras theorem. Let AB, we assume here AB is a ladder and CA is a wall in with the window at A. BC is given 2.5 and CA is given 6 meter. According to Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. 2.5 square, that is equal to 6.25. 6 6 is 36. When we add both, we can we find 42.25 and take its square root. When we take its square root, then we find 6.5 approximately value of AB. And this is your AB, and this is your answer, length of a ladder. You can find it by this method. 6 6 is 36. 12 minus 6 6. 6 6 12. take 5.5, 625. You can see 6.5 is the length of ladder. In a 12th question, 12th example, we have given AD perpendicular BC, and we have to prove AB square plus CD square is equal to BD square plus AC square from triangle ADC. AC is equal to, this is a hypotenuse, perpendicular, base. So according to Pythagoras theorem, AC square is equal to AD square plus CD square, and from triangle ADB, in this we take here AB is hypotenuse, and this is a perpendicular, and this is a base. So AB square is equal to AD square plus BD square according to Pythagoras theorem. From first and second theorem, when we subtract first theorem from when we subtract first equation from second equation, we will find AB square minus AC square is equal to BD square minus CD square, because this will cut with this will, and AD square cut with AD square, and we will find AB square minus AC square is equal to BD square minus CD square. AB square plus CD square is equal to BD square plus AC square. This is proved. We have to prove this. Interchange the signs and places. Now in 13th example, BL. In this question, in this example, according to this figure, we have given BL. This is a BL, and this is a CM. Both are medians of a triangle ABC, right angled at A, and prove that 4 bracket start BL square plus CM square is equal to 5 BC square. For proving that, first of all, write BL, CM both are the medians of triangle ABC in which angle A is a 90 degree. These statements are given in question. You have to write as it. From now, take the first triangle ABC. Where is the triangle ABC? This is a whole triangle. This is a triangle ABC. In this triangle, BC is taken as a hypotenuse. This is a hypotenuse and is equal to base will be AB. AB square plus AC. AC is a perpendicular, because here it show the 90 degree angle. According to Pythagoras theorem, it is a first equation. Now take the ABL. Now take this triangle, right angle. In this triangle BL is a hypotenuse. So hypotenuse BL square is equal to, and base is taken AL square plus, and perpendicular is taken AB plus AB square. Now next, BL square is equal to AL square. AL square is the half of AC. So we can write it here as AL's place value AC over 2 whole square plus AB square. Because L is a midpoint of AC, so that's why we can write here instead of AL, AC over A2. When we solve it, AC square over 4 plus AB square, and take the LCM. BL square is equal to, take the LCM, AC square plus 4AB, and by cross multiply 4BL square is equal to AC square plus 4AB square. This is your second equation. Now take the triangle CMA. Now take the triangle in CMA. This triangle is made here. You can see this diagram is like this. CMA, BL. This whole is proved. This also proved. Now we have to prove CMA. Now we have to take this triangle. In this triangle, CM is a hypotenuse, base is AC, or AM is perpendicular. CM square is equal to AC square plus AM square. Now you can put AM in place of AM square value. We will take here AB over 2 because CM is the median of AB. So that's why we take here AB over 2 whole square. CM square is equal to AC square plus AB square over 4. Take the LCM. CM square is equal to 4AC square plus AB square over 4. After by cross multiply, we get 4CM square is equal to 4AC square plus AB square. This is your third equation. From when we add second and third equation, we find that 4BL square plus 4BL square plus 4CM square is equal to AC square plus 4AB square plus 4AC square plus AB square. You can see, and when we add both sides, we find that 4 common. BC square plus CM square is equal to, here 4AB square plus 1AB square, that is 5AB square. 1AC square plus 4AC square, that is 5AC square. You can take here 5 common. AB square plus AC square. You can see AC square plus AC plus AB, that is equal to BC square. You can write here 5BC square. You can write here, and this will be prove the question. Now in this example we have given, this is very important, O is any point inside a triangle ABCD. Prove that OB plus OD is equal to OA plus OC square. For solving this, first of all, write through O. We draw a line PQ for proving the equation. Draw PQ parallel BC so that P lies AB and Q lies DC. PQ parallel BC. PQ parallel AB and PQ parallel DC. Both are 90 degree. Both make the 90 degree angles. Now take angle BPQ is equal to 90 degree, and CQP, that is also 90 degree. Therefore BPQC, this is a one triangle. PQDA, this is another triangle. So both are another rectangle, and both are rectangles. In both rectangles we have given triangles. Triangle OPB, this is first triangle, this is second triangle, this is a third triangle, fourth triangle, fifth triangle, sixth triangle. There are 6 triangles totals are given here. Now first we take first triangle OPB. OPB hypotenuse square is equal to base square plus perpendicular square. OB square is equal to BP square plus OP square. This is a first equation. From triangle OQD, we find OD square is equal to OQ square plus DQ. We have to make here all triangles equations according to Pythagoras theorem, and first add first 2 equations. OB square plus OD square, BP square plus OP square plus OQ DQ square plus. When we plus all these, we have to we can write here, instead of BP we can write here CQ, because BP is equal to CQ, DQ is equal to AP. So we put here BP's place CQ and DQ's place AP square. CQ square plus OQ square plus OP square plus AP square. From both, from this we can combine it. When we combine it, it will be converted into OC square. It will be converted into OA square, because P and in this Q is common from third and fourth equation we find. Now you can see OC's value this and OA's value this. So that's why we can convert it. Now this is a proof, because in this question we have to prove that this will be proved. If you like my video, please like and share my channel for next coming videos. And don't be forget to revise all illustrations of math, because all illustrations are very important for exam point of view, which will be held in March 21st 2023 of CBSE, according to CBSE board. Revise it. If any problem, you can send me your query in comment box. Either you can send in comment box or you can send me mail. This is my mail ID, omrachu.for1081@gmail.com. You can send here queries. I will solve your queries. Or you can join my Telegram channel, ROAV Perfect Classes. When you search ROAV Perfect Classes, you will find my channel. You can join it or send your queries according to your questions. I will try to solve your questions in next coming videos.